Today we'll be talking about things that particularly backhaul and transport networks need to do to meet the 10x challenges of the 5G era. So thank you for joining. Let me fill with this. So just a quick word about ribbon for 5G transport. Ribbon has not exactly been a household word when it comes to optical and Ethernet networking, but in March of this year, Ribbon Communications acquired a company called ECI Telecom. ECI has been around since the 1960s and has been a long-time leader in packet and optical networking around the globe. In particular, the new solutions here are leaders in deterministic forms of transport, which is very important for 5G. We've built huge 4G backhaul networks in Asia and Europe, made a significant investment in 5G backhaul, and we partner with Ericsson globally on a number of projects around the world. Ribbon, of course, is headquartered here in the U.S., and we're traded on the NASDAQ. So that's a little bit about who we are. If you're pressed for time this morning, this is the world's first 30-second webinar. If you don't hear one slide, you can, please listen to this. We're really particularly talking about cable companies today, but this is applicable to a lot of folks as well. MSOs make lots of money delivering backhaul services for mobile operators for 4G today. The problem is the current 4G backhaul networks and services, they're going to struggle greatly to keep pace with the new 5G needs. And these new 5G needs are what we call the 10x challenge, and we'll show you why in a few slides. So what that means is for MSOs and other carriers, the backhaul revenue stream is probably going to be in jeopardy. So new backhaul solutions are going to be needed. We happen to have them. Things like the solutions that provide things like network slicing, a higher quality of synchronization, and deliver a lower cost per bit. So that's what we're going to talk about today. And I guess I'll turn it over to David here to take us through a few slides on some important market trends.
Wow, thank you, Sam. And 2020, what a year. I thought I'd leave an old slide up before that we'd put up at the beginning of the year. And just to say really that the projected growth of 5G hasn't been affected by what's happened throughout the rest of the world over this year. In fact, the growth has been quicker than anticipated by this slide, which I say was the back end of last year, early this year. And everything has started with base station rollout, of course. And there have already been over 100 5G commercial launches. And we've seen from the middle of this year onward, the start of the first standalone 5G network. So really moving at a pace, almost in disguise because of what else is happening in the world. And of course, with that rollout, you don't really get subscribers until you have the devices, the phones and stuff. And there's already 100 commercial 5G devices out there. And iPhone even launched its 5G model in October, as everybody knows. And this will continue to drive subscribers up over the next few months. So in terms of subscriptions, Ericsson in their monthly report from November said they expect 220 million subscribers by the end of this year. A year ago, they were predicting 190 million. So it is really growing faster than was anticipated, and that was fast anyway. The other thing to mention, specifically around 5G, as opposed to 4G, there's actually definitely a first mover advantage. 4G and 3G before it were targeted at consumers providing best effort mobile broadband and connectivity respectively. In reality, it wasn't actually difficult for a company or a country to catch up if it launched late. However, with 5G, it's targeted at far more than this best effort connectivity. And the sort of markets it targets is quite difficult to catch up if you lose the first mover advantage. For example, enterprises and industries have seen and quite like the idea of the deterministic URLLC and mass connectivity promised by 5G. And they know, and it's been shown that enterprises are able to move towards Industry 4.0, embracing the productivity, flexibility and quality improvements that this brings, also give them a commercial advantage. And then once you start behind, it's very difficult to get catch back up, particularly if a country is not invested in that infrastructure. So 5G really does have that first mover advantage. And again, in the consumer space, we start to see an advantage for new high value services, community services that need more than just a best effort broadband connectivity. And gaming, as we will see on the next slide, is an example of that, where you need deterministic connectivity. So if we move to the next slide, Sam. So cloud gaming, thank you. Cloud gaming has actually been bubbling around in the background for over a decade now. I think 2007 was the first time someone showed me a cloud gaming type thing. And products like PlayStation Now and NVIDIA's GeForce Now and others have been bubbling around below the market, big market breakthroughs. And it failed to really take off big time due to latency issues, or as gamers call it, lag, and low bandwidth in the access network. However, more recently, as the access connectivity has improved, we have started to see massive growth in this mobile gaming market. And today there's more than 2 billion mobile gamers. And the Call of Duty, which was launched in October last year, managed to rapidly gain 100 million users when it launched. That incredible launch. I mean, it didn't hurt that they offered it free to start with in-game purchases, but even so, a massive ability to grab interest and end users. But it's not just the games. We've also seen the launch in the last 12-18 months of a whole set of new cloud gaming platforms. And I mentioned PlayStation Now and GeForce Now. But in addition to that, we saw platforms like Google Stadia, Microsoft's xCloud, and more recently, the Shadow solution by Blade, which provides a sort of true mobile gaming service where you're able to link to a Windows 10 machine housed in their virtual edge compute type environment. Really quite exciting platforms for gamers. However, lag is still an issue. And this is where advanced features offered by 5G fit. And indeed, research that we did earlier in the year, or sponsored earlier in the year, showed that gamers will, and actually are willing to pay extra money for a network which reduces lag. So anyone who can provide gamers with this a low lag, high reliability network will capture a big chunk of these gamers. And any wholesaler is able to wholesale the transport network that allows the mobile network operators to do that, will be at a significant advantage at capturing that really valuable backhaul market. So it's not just the ability to provide IP and optical transport, the ability to provide somewhere to house edge data centers, for example, gives those wholesalers a massive advantage. So moving on to the next slide, Sam.
There you go.
So yeah, what would that sort of transport network look like? Well, firstly, it's not surprising to discover that the transport network for 5G is going to look totally different to those networks used for 3G and 4G. Gone is the single homogeneous transport network, which used to provide static, nailed-up connectivity between the 4G radio resources and the associated mobile core. Instead, 5G requires a dynamic network able to assign deterministic connectivity and capacity wherever it is required. And you may ask, or scratch your head, why is all this complexity needed? Well, as ever, let's start with the services. 4G focused on providing best effort mobile broadband, and it really does that exceptionally well. It built on the lessons learned from 3G and built a platform and an architecture that's absolutely well suited to deliver mobile, best effort mobile broadband. And so well, in fact, that many services and industries could see the advantage that mobile connectivity had to bring to their business and wanted to get involved. So that's where we started to see requirements coming into the 5G, the standards, and now into the rollouts that allow it to be used for these business and services. At the same time, mobile consumers are looking to run new types of services which require deterministic and assured performance in terms of latency, like the gamers, reliability for, say, remote consultations if you're doing eHealth, and in performance of the network in general. So instead of providing mobile broadband, 5G supports services using mobile access for connectivity. It's a really important difference. Mobile is not the first word here. It is providing real services, end-to-end services, and the access medium is mobile. Makes a big difference. These services can and do have totally different requirements. Someone surfing the internet has a totally different set of needs from, say, a doctor doing a remote consultation via HD video link, or a virtual classroom using mixed reality AR and VR for immersive type education services. These different services need networks that perform completely differently in terms of latency, reliability, security, capacity, and availability. And it is not cost effective or indeed realistic at all to build a separate network for each service type. Instead, we have this concept of network slicing, and Sam will explain this in a bit more detail later on. But in a nutshell, with network slicing, the whole network is reviewed as a resource pool of physical network functions, PNFs, virtual network functions, VNFs, and cloud network functions, CNFs. And a slice is created for each service type by combining the relevant network functions to meet the service performance required. A slice also has the added advantage of providing hard or soft isolation between the services as required or if required by the service, and Sam will touch on that again later. These new services and the ability to deliver them cost effectively has driven the need for a paradigm shift in the mobile architecture itself. Gone are the monolithic RAN and mobile core of 4G. In 5G, these have become virtualized and disaggregated. The radio is split up into radio unit RU, distributed unit DU, and centralized unit CU. And the vision is that you can instantiate the DU and CU functions whenever and wherever required, giving them more compute and more storage if required. And the same is true of the mobile core, where we split up that monolithic mobile core into multiple functions and allocate them where they're required. And this includes splitting the control plane and the user plane in something called control and user plane separation, or CUS. The job of the IP and optical transport network is to dynamically provide the connectivity and capacity to each of these functions, wherever and whenever they are instantiated. And this connectivity must meet the performance criteria of the services that you're looking to transport. And Sam will go over some of this in a lot more detail over the next 4 or 5 slides. Thank you, Sam.
Okay. Yeah, thanks, David. So the bottom line here is today's transport networks really weren't built for 5G, and let's talk about that in more detail. So if we look at the next slide here, for those of you following along, basically 5G is going to change everything. So if you look at the job of the transport network, to connect the RAN with the core, regardless of how the core is distributed, there's kind of 5 things that change dramatically in 5G. First of all is the bandwidth, the capacity. It's going to be at least a 10 times increase in the amount of bandwidth that needs to be backhauled. But I don't think the mobile operators are going to want to pay 10 times as much money. So the transport operators like yourselves are going to need to figure out a way to bring that bandwidth back more cheaply. Synchronization that is often going to have to be delivered by the transport network is going to have to be 10 times more accurate. The topology is going to have 10 times the quantity of endpoints. There's going to be a 10 times or greater than 10 times reduction in the latency required for specific applications. And then finally, network slicing. The best way to think about network slicing is the network is a single transport platform or environment. And out of that single transport environment, as a backhaul operator, you'll need to deliver, say, on the order of 10 different kinds of network types to satisfy all the different demands of the mobile operators that you're serving. So, some people say they shouldn't call it 5G because it's so much different than 4G. Maybe we should call it 10X. I don't know. Bottom line, 4G transport networks are not going to be sufficient for 5G. So let's just look at some of these in detail now and talk about 5G capacity increases and interfaces that are going to be required. If you look at the bottom there, you can see LTE. Most of the time it was 1 gigabit Ethernet interfaces off the cell site router of the mobile operator into the transport network. That's already changing to 10 gig with LTE advanced in some cases. But with 5G, it's going to be 10 gig, it's going to be 25 gig, and there's going to need to be 100 gig uplinks from the cell site routers that the mobile operators have in the future as well. In the aggregation network, again, moving to 25 gig and 100 gig E interfaces with over a terabit of throughput. And then kind of in the metro core, if you think about it, 100 gig E is not going to be enough. We're going to have to move that to 400 gig, where things like ZR optics are going to be helpful, and providing 5 to 10 terabits of throughput. So you see about a 10 times increase in terms of the capacities required from 4G to 5G. And again, there's going to be a lot of pressure on transport operators from the mobile provider to say, I need a lot more bandwidth, but I don't really want to I don't want to pay you 10 times the amount of money. So that's going to be an issue, how to do it cheaply. The next big thing is 5G synchronization. A couple of things. If you think about the massive amount of bandwidth that a 5G radio is going to need to deliver, in some applications, those 5G radios actually need to talk to and communicate with one another and actually share the load of delivering bandwidth to the user equipment. So in order to do that, those radios need to be synchronized with each other very, very tightly, actually a factor of 10 more tightly than today. If you look at the little table on the right hand, the end-to-end time accuracy of the different radios needs to be with 1.5 microseconds of each other for 4G. That moves down to 130 nanoseconds for 5G, so that the radios have to be more tightly synchronized. And the network itself is going to play a much more important role in delivering synchronization. GNSS receivers or GPS receivers, they make up a large percent of small cell site costs. So as 5G becomes more densified, people start building small cells. GPS is going to be harder to rely on exclusively, so the network is going to have to participate. So if you look at, there's many different ITU standards for synchronization. The one maybe to think about is the G.8273.2 set of standards, and they outline Class A, Class B, Class C, and Class D timing capabilities. Class A and Class B are what's in most Ethernet switch routers today that are used for backhaul. Class A and Class B is probably not going to be good enough. You're going to need Class C or possibly even Class D timing support, but Class C will probably suffice. So that alone is going to bring big change to the transport network. Next, let's talk about latency and slicing. We'll kind of talk about those two things together. This was a survey that IHS Markit did earlier in the year. They surveyed a number of different service providers and said, these are the important factors if I think about 5G, and providing ultra-low latency transport is the key issue, and then closely after that was network slicing to deliver the end-to-end performance. So we'll talk about these in more detail in our next section, but network slicing, low latency, very important things for this backhaul network to deliver. And with that, let's take a little bit of a break here. And Lance, I think we have a poll question for the audience. This will be fun for everybody, so stay tuned.
We do, and yeah, thanks, Sam. These have become sort of semi-famous, I would say. But here's the poll question. Vote for your punchline you would like to hear from the jokes below. And so stick around to the end where Sam will deliver the answer to one of these jokes, punchlines. So first one, what is a pirate's favorite letter of the alphabet? Number 2, what do you get from a pampered cow? Who knows? What do Alexander the Great and Winnie the Pooh have in common? Good question. And the last one, a guy walks into a bar and orders 10 shots of single malt scotch. So take a minute, click on which one of these punchlines you'd like to hear or which one of the punchlines you want to hear at the end, and we will deliver that here towards the end of the webinar. Sam, any thoughts on these? What you're thinking here might be the winner?
Well, my advice is to vote wisely. Some of these jokes are punchlines are really bad, so you don't want to make a mistake. I mean, this is kind of critical. This is like,
It's an important decision.
okay, pouring in, the responses are pouring in. Usually when we've done this before, the jokes about people walking into a bar tend to be the most popular, but I wouldn't say they're always the best, but anyway, so thank you for your votes. Vote one, it's election season in the U.S. We just got done, so you're all practicing. If you're a U.S. participant here on the webinar, you're used to voting often and voting regularly. So please go ahead and vote for your favorite.
All right.
Okay.
Okay, we do have plenty of responses here. You want me to go ahead and close it out, Sam?
Yeah, punchline at the end.
Okay.
So let's move back to our regular presentation. So ultra-low latency and network slicing are going to be really important for 5G. And let's talk about that in a little bit more detail. Let's talk about what a network slice is. There's, as I talk to customers very regularly here in North America, and sometimes there has been confusion on what a slice is. Most people have sort of heard of slicing, but not necessarily familiar with some of the details. So basically, and you often hear people say things like, well, I can deliver a VPN. A VPN is basically a slice. Well, a VPN is a technology that people are thinking about using to deliver a slice, but it's not necessarily the same thing. So a VPN, if I can contrast, does a really great job, either a layer 2 or layer 3 VPN, of defining closed user groups so that, the purple person's traffic doesn't talk to the pink person's traffic there in the graphic. But those VPNs are delivered over shared resources, and all the VPNs have very similar types of behaviors. And because it's over a shared resource, the SLA that the service provider can offer is, let's say, statistical in nature, which says, okay, on average, I'm going to give you a packet loss that looks like this, or on average, I'm going to give you a packet delay or delay variation that looks like that, but I really can't guarantee it all the time. Yeah, 95% of the time you'll be quite happy. 5%, well, that's kind of the best I can do because I'm sharing resources on this network and getting some stat muxing and that sort of thing. A slice is a little bit more of an advanced concept. A slice I like the GSMA's definition of this, which says a slice is a dedicated network on a common platform. And what that means is you get a much greater, there's still some sharing for economic purposes, but you get a much greater isolation of resources. So the pink person there with their network and the purple person there with their network, they get performance as if they are on a separate network. And those networks are separately managed. So there's a potential then for each slice to have different network behaviors and different network performances. And now the backhaul operator, the MSO, or whoever can offer a more guaranteed form or a higher quality form of SLA, which is going to be very important for some of the more exotic 5G services like the URLLC category of services. So that's what a slice is at a high level, and it's more than just a VPN. And if I can advance the slide, I will do so. Look at this. So slicing the transport network is essential for 5G. There's lots of different reasons to slice a transport network. If you talk to different folks, they might point to different things, but they're all valid. The first one is multi-tenancy. So for example, if you're a backhaul operator, like a cable company here in the US or Canada, multi-tenancy might be important for you. You might have many mobile operators at the same tower location or small cell location, and they'll want to lease transport from you to come back to the distributed core. So you're going to have many MNO tenants, single backhaul network. It'd be really reassuring to each of your mobile operator customers to give them not just a VPN, I'm going to give you a slice that can be separately managed with its own unique behavior. That's a really important business opportunity, I think, for backhaul operators. People talk a lot about the new 5G services and the need for slicing among those, like there's EMBB, URLLC, ultra reliable low latency connectivity, MMTC, and people sort of talk about, and let's create different slices for those different service types. That might be a thing. People also talk about building slices for targeting specific industry verticals. Critical infrastructure verticals, for example, that have specialized OT or operational technology applications very latency and loss sensitive, or there's sort of conventional IT applications that are a little bit more loosey-goosey, but still the idea is I'm going to create a slice for like a mobile operator might say, I'm going to create a slice for healthcare, I'm going to create a slice for critical infrastructure, and then you as a backhaul operator will be able to honor those types of slices that your mobile operator customer defines. And this idea I thought was pretty neat, the idea of use case clusters. This was an idea proposed by our partner Ericsson a couple of years ago, and they kind of recognized that there are applications, for example, like AR, VR, that could apply across a number of industries. So instead of defining a slice per industry, then there might be a value in defining a slice per application. Say, here's my AR, VR slice, and as a mobile operator, I'm going to sell that slice to a bunch of different verticals. And then as a transport operator, you folks will be able to say, yeah, Mr. Mobile Operator, I can support your AR, VR slice this way in my transport network, because the slice doesn't work if it's just in the RAN and the core. It's got to work across your transport environment also, and that's where you're going to add value. So let's look at different technologies to provide these kinds of slices through that transport network. There's technologies that provide hard forms of isolation between different slices, and technologies that perform soft isolation between the different slices. So hard isolation, it's basically dedicated resources, and think time division multiplexing. So you get very strict separation between the slices. It's literally not possible for traffic congestion in one slice to ruin traffic in another slice, and they're very simple to provision. They're just pipes. So you get perfect isolation, perfect service level agreement guarantees, almost like a wave service kind of thing, but you don't get any statistical multiplexing across pipes, so it's really going to screw it. It's going to be costly. All right, so if you only have hard isolation, it's going to be costly. It may not work in every case. Soft isolation, you have sharing of resources. So think about the VPNs that we talked about a couple of slides ago. It's true, traffic of one VPN can't be received by customers on another VPN, and it can be very cost effective with stat muxing. The problem is you get imperfect isolation where congestion in one VPN can actually impact other VPNs, provides the statistical SLA that we discussed that may not be sufficient for emerging 5G applications. The type of slicing that we advocate at Ribbon in the transport network is something we call, I don't know if I like this name honestly, but it's the best one we could think of. Hybrid slicing in the transport network really gives you the best of both worlds. So let's look at hybrid slicing for 5G. We have the soft slicing over here, 4G backhaul VPNs, great stat muxing, and statistical SLA. And hard slicing, you can think private lines, private wavelength services. You get great isolation, but it's underutilized. If you kind of do the best of both, you get something that looks like this picture on the bottom. So the one giant pipe here is you can think about as a 100 gig or 400 gig line side network interface somewhere in your transport network. And inside that biggest pipe, you've got other pipes that are defined. So the gray pipe, the gray shaded smaller pipes, those are your hard pipes. In this example, we've got 3 of them. And inside each hard pipe, you run segment routed VPNs. So that gives you your stat muxing capability and your efficiency, but it's inside, those VPNs are all contained within hard pipes, so the VPNs don't collide with one another across hard pipes. In particular, the technology we recommend is segment routing for the VPN. Segment routing has better traffic engineering properties, and it eliminates the RSVP-TE scaling issues. But you get guaranteed isolation across the hard pipes. You also get stat muxing efficiency now because you've got VPNs going on inside, and you've got choices for the type of hard pipe or the size of hard pipe that you want to implement. So that's hybrid slicing. It's good for the 10x challenges, and it is, if you're looking for a quick definition, a hybrid slice is a VPN inside a hard pipe. Okay, and that's a pretty key concept here. And what this does, and this is something that we have proof of concepts available to demonstrate to folks, and we're actually doing We're actually doing POCs on this for customers around the world. So if you're interested in us doing a POC for you via video, we'd be very happy to do that. And what we can show is behavior like this. If you look at the picture on the upper left, you get great isolation of traffic with hybrid slicing. So this shows two hard pipes, hard pipe number 1, hard pipe number 2. Hard pipe number 1 is for things like the web. Hard pipe number 2 is for mission critical traffic. And for your web EMBB kind of traffic, you're going to want to oversubscribe that so you don't lose your shirt economically. So you got EMBB VPNs, they're oversubscribed. I get some congestion, and guess what? I get packet loss, delay, and delay variation for stuff coming out the other side. Okay, but that's okay because that's web-based traffic. Within hard pipe number 2, that's your mission critical stuff. And you got mission critical VPNs in there that are absolutely untouched. That's the magic. Zero impact to mission critical traffic if you have congestion with your non-mission critical stuff. Now, if somebody is doing soft slicing only or VPNs only, it's more like the picture on the lower right-hand side. There's your 100 gigabit Ethernet interface. You've got a bunch of EMBB VPNs and mission critical VPNs, and they're just kind of all tossed in the same pipe together. You get congestion on your internet stuff, and it's going to bleed over and impact the mission critical things. So with hybrid slicing, you have the opportunity to sell a transport service offering that is differentiated really over any kind of transport backhaul service that has existed for 4G. So this is an opportunity for you to look unique to your mobile operator customers. You will see, if you know, we've all been attending tons of webinars today, and by the way, thanks for hanging with us. If you attend tons of webinars, you'll see some folks out there in the webinar world that say, you know, control plane isolation alone, that's what I really need to do. The control plane isolation creates logical isolation for topology, path computation, and it's done with a virtual routing type of approach. Virtual routers may still vie, though, for common resources, so control plane isolation alone does not and cannot eliminate data plane contention. So what we're really focusing on is the data plane part. We have the control plane as well. I mentioned earlier that we have different hard isolation user plane choices. There are 2 that would be prominent. The first one is OTN, and that is, of course, a layer 1 technology where you can define containers in multiples of 1.25 gig all the way up to 100 gig or more. They're very low latency containers. You can build point-to-point ring mesh, 50 millisecond protection. Those types of hard pipes are typically implemented on optical classes of equipment, usually. And so the other type of isolation, the hard pipe isolation, is called Flex-E, which is something developed by the OIF, which has been extended now by the ITU to G.MTN. MTN stands for Mobile Transport Network. And basically what Flex-E or G.MTN allow you to do is you don't have to invoke the optical layer. You basically just invoke a packet layer. And what GMTN allows you to do is to take a 100 gigabit Ethernet trunk and chop that up actually into multiple of 5 gig TDM transport slots. Each of those transport slots then, as it goes through the network, is not buffered or queued or scheduled or anything. It's very low latency. I can build any kind of topology. I can get 50 millisecond protection. And the Flex-E G.MTN hard pipe is not invoked on optical equipment usually. It's invoked now on packet equipment. So I can actually have a single switch router device doing the segment routing VPN soft pipe inside a Flex-E G.MTN hard pipe, and I can do that on one type of equipment. Just briefly, actually a trend we're seeing in North America is people do use in some cases a hard pipe only for backhaul, and they do that because it's simple, it's guaranteed. Excuse me, I'm going to sneeze. That's the first time I sneezed on a webinar. I hope nobody missed that. It's simple to deploy, it anticipates capacity growth, and it can be encrypted. So some people are going the hard pipe only route. What we're seeing more is people looking at the hybrid slicing and both methods. We talked about the hard isolation choices earlier. Let's talk about the soft isolation choices. Yeah, typically, people have used RSVP-TE-based VPNs. They're widely deployed. They're well understood. The resource reservation, though, typically occurs only at the endpoints only. because RSVP-TE has some problems with scaling, both in terms of its complexity and the number of resources that it uses, and the SLAs, therefore, because it's not just deployed only at the endpoints, the SLAs are statistical in nature, and again, not adequate for some 5G services. Segment routing with traffic engineering is a better way to go. It's an emerging routing protocol. If you're not familiar with segment routing, it uses centralized path computation, and it's much more scalable to give you per hop resource reservation by reducing the amount of state that the network needs to maintain. Basically, with segment routing, the magic is every time there's a packet that comes into the network, the information about how that packet is to be treated is contained in the packet header itself. So the nodes don't need to remember much of anything. They just see the packet come in and says, oh, that's how I need to be treated. Okay, I'll treat you that way. And the path computation is done centrally. So that's going to be a very key technology for 5G backhaul. It's interesting. I talked to some smaller operators, again, in North America, and some of the smaller operators have built backhaul networks really actually even just based on Ethernet provider bridging. That was fine for 4G. It's probably not going to be fine for 5G. It needs something much more sophisticated. So here's a picture then of how to do hybrid slicing in the packet world only if you don't want to move to an optical layer. And the idea is you provide G.MTN hard pipes and segment routing with traffic engineering VPNs inside those hard pipes. So I've got a 4-node network here. My segment routed VPN connections come in on the left-hand side from the RAN. They go out on the right-hand side toward the core. And G.MTN is a full-blown network layer. So if there's a failure in the network, like that little blue explosion, the node downstream from that sends OAM traffic downstream, and there's a protection switching event that occurs at the end. So you get 50 millisecond switching. I don't need to provision like a fast reroute function. And I get cut-through switching at intermediate nodes, like that node at the top of the picture there. I can just bypass that G.MTN pipe right through the node if I don't need to add and drop VPN connections in and out of that. So I can get a 10 times reduction in latency on a through node because the G.MTN pipes are not scheduled, buffered, queued, fold spindled, or mutilated. They just fly right on through. So G.MTN plus segment routing and traffic engineering in a single platform can do both a hard and soft hybrid slice. And with that, I think we're getting close to the end. David, you want to just real quickly take us through a couple slides on our solution?
Yeah. Thank you, Sam. It's very informative. So you can't do a webinar without talking about what we do at Ribbon. And we provide a complete portfolio for providing the 5G transport that Sam's just described. Whether this be our Apollo optical transport portfolio, which is used to provide the optical transport and OTN switching, which Sam described earlier, or it be the Neptune portfolio, as shown here, which is our multi-service IP transport and aggregation portfolio, which we use to dynamically provide the deterministic IP transport, which is fundamental for the new 5G services. As we sort of explained earlier, and Sam alluded to on how you set up the VPNs and the hard and soft slicing. And of course that becomes really, really important for the evolution of IP transport in general as we move further into the 21st century. I think we'll see more networks, not just mobile networks, needing to move into more deterministic and dynamic provision of deterministic services. So I think as a transport network operator, you're very in an ideal place to put this sort of network in place, and that will serve your current needs for your fixed infrastructure and also wholesale stuff to mobile network operators. The Neptune portfolio itself is a full range of platforms, ranging from devices which are 1 RU in size, providing the highest density one we've got, 1 RU is 300 gigabit switching capacity, through to an 8 RU box, which has a switching capacity of 2 terabits and multiple slot options. So a full range of platforms. These platforms are completely modular. To say, you can plug in and out of the boxes, various chassis cards, and cages to allow you to modify your service mix. And also we can plug in service extension units to these boxes to allow you to grow capacity without having to rip and replace. I shouldn't move past this slide without mentioning our latest platforms that we've added to the portfolio, being the Neptune 1100 and the Neptune 1250. And these are really ideal for 5G and also the next generation IP transport. The Neptune 1100 provides this 300 gig switching capacity I mentioned in just a 1 RU footprint, making it really ideal for use as a cell site router if you look at the capacities that Sam mentioned on that capacity slide. And the MPT 1250 is a fully redundant multi-service platform which supports the FlexC that we mentioned earlier and the advanced timing and synchronization. It fits in the 2 RU footprint and is really targeted to be, indoor or outdoor mount, and is really targeted at the pre-aggregation type applications, although it could go in the aggregation space in some smaller networks. And with its ability to be mounted outdoors and fitting into RU, we have some examples of where it will and can fit into street cabinets alongside other access equipment that you may have. So really quite exciting additions to our packet portfolio. And then of course we support all of those packet technologies that that Sam mentioned earlier, the SRTE, IPMPLS clearly, hybrid slicing, all the OANM that you'd expect. And then with all networks these days, they've got to be able to be have open interface to be managed by our own management system or anyone else's for that matter. So then moving on to the next slide.
Trying. I do have a master's degree. Let's see if I can do this. Okay, there we go.
Of course, you can't have a network without some way of controlling it. And the control system or orchestrator, in this case, is actually fundamental to how 5G or any next generation transport network will operate. As we move to more and more complexity, you need more and more intelligence and more automation within that orchestration system. And that's what we have with our Muse domain orchestrator. It is able to manage the full life cycle of the IP and optical transport network itself, so the network devices, and all of the services that are transported across that network. So full end-to-end lifecycle management across those networks in a seamless way, so you don't actually have to say this is just optical, this is IP, we won't talk to each other, it's your fault, it's my fault. Really integrated multi-layer integration for both provisioning and assurance. Now as we focus down onto the 5G, within the Muse domain orchestrator, we have a number of applications building containers that allow you to add more and more applications to the domain orchestrator as you want. So one of the key ones for 5G, or the key one for 5G probably, is our advanced slice manager application. And with this, you can define and provide the continuous management of the multi-layer network that Sam explains is required to achieve slicing. So that includes your slice definition, the fulfillment of the slices, assurance of the slices, monitoring the performance of the slices, and continually optimizing those slices and the VPNs that ride on the slices to make sure the network's working at peak performance and meeting all those SLAs that we need to do it. To achieve this, we've built our Muse domain orchestrator on top of a carrier-grade PaaS platform, which, of course, as those of people who know about this sort of thing, ensures that scalability and high availability that you can get from these modern types of PaaS platforms. And our IP and optical transport network, or the IP and optical transport network that you would deploy to service the MNOs, is just a small part of the 5G ecosystem. So you absolutely have to have open interfaces to plug into the wider 5G ecosystem, whether that be providing interfaces to end-to-end domain orchestrators or providing interfaces to customer network management functions where you can rent capacity to a mobile network operator. They can have a customer network management function looking at the network they've rented or leased from you, that is completely, again, isolated, complete operational isolation of the resources within their network that they've leased from you, completely operationally isolated from another part of that network. Again, fundamental to be able to offer bits of network to other operators. And the multi-domain orchestrator provides you all of that. So moving on to the next slide, Sam. So for MSOs and transport network operators, what does this all mean? Well, your network by definition is going to have to be multi-tenanted. You have to support your own services. You want to lease backhaul capacity to as many mobile network operators as possible. You know, with economies of scale, the more you can lease to more operators, the more money you're going to make, the cheaper it is for you to put in place. So by definition, you need it to be multi-tenant. Also, as I've sort of hinted out there, you're not just going to build a bespoke network to do mobile backhaul. You may do if the money's there, but you've got a network in place anyway to provide your own internal services for what you're doing. If you're a cable co providing the infrastructure for the cable backhaul, you might be offering business services. You might currently be offering residential services. So your whole gamut of services, you need a multi-service set of platforms that allow you to do that. And you'll want to be able to offer, when you do offer mobile backhaul services, you want to be able to offer them differentiated type services. So, as I mentioned right at the very start, or alluded to right at the very start, you might want to offer a transport service that's ultra low latency and bundles in maybe some resources or some racking, or even the MEC itself, so where you can actually put the transport network in place, but you can also put some edge compute in there as part of your bundled offer. I mean, that's just one example of a differentiated service. You might want to guarantee one which is ultra high reliability, another differentiated service. So these are the sorts of things you need. We at Ribbon provide you with a multi-layered technology called toolkit that allows you to achieve this. So with our cloud native slicing and the automation given to it by Muse, we're able to give you a seamless way of providing this slicing across an IP and optical transport network using our hybrid slicing routers in our Neptune portfolio and our automated next generation optical portfolio for when you want to go for the harder slicing based around OTN, etc. So it's really important that this network you put in place is able to support multiple needs for multiple operators, and you have the toolkit to move as your customers move. And I think within the Ribbon portfolio, we're able to do that. So I think Sam will just conclude, and then we'll go to Q&A.
Okay, that sounds good. Thanks, Dave. Yeah, let's try to wrap up here, getting close to the end of everyone's time. So, you know, as an MSO, a cable company, or a backhaul operator, are you ready for these 10x challenges that 5G is going to provide? We talked about the 5 or 6 things the network is going to need to do. Today's carrier Ethernet-based networks are going to be inadequate for 5G transport. Actually, we've seen this in a lot of operators. I guess I didn't talk about this. A lot of operators, those networks are becoming inadequate for 4G today, and they're moving to next generation solutions. We advocate something called hybrid slicing for all backhaul services and multi-tenancy applications, leveraging both FlexE, G.MTN, and segment routing. And you can actually use the same solution set for higher bandwidth 4G transport. So if you're not serving mobile operators who are 5G capable yet, but you find your 4G backhaul network is sort of running out of gas, you can take this solution set, use it for 4G, and it'll be ready for when your mobile operator customer moves to 5G. So that's it. Thank you for joining, and thank you for your time. And I guess, Lance, you want to wrap us up with any Q&A and poll? We owe you a punch poll.
Yeah, I know everyone anxiously awaiting that. But we do have one quick question. I've heard that MEC is really important in 5G. So why exactly is this? Is the question.
Yeah, Mac, maybe I'll just take If that's okay. So MEC is mobile edge computing, or sometimes called mobile access edge computing. And that's the idea of distributing compute, storage, application resources that the end user is actually trying to access. You distribute those things farther out into the network. And they're especially important for latency sensitive types of applications, which will become more important with 5G, that URLLC category of applications. So what this means for the backhaul network is, usually backhaul networks today, they gather traffic from a number of different cell tower locations, and they backhaul it to a handful of mobile switching offices somewhere in the metro. So very few backhaul destination points. With MEC, those backhaul destination points are going to proliferate very, very widely.
Okay. Very good. Well, thank you for that answer, Sam. And I think, like you said, we're almost at the top of the hour here. So without further ado, do you want to deliver the winning punchline, I should say?
Yeah. What was the joke that people wanted to hear?
Oh yeah, let me look at that. One moment, let me pull it up. So the winning one, as expected, a guy walks into a bar and orders 10 shots of single malt scotch.
Oh, I'm so sorry. You all are going to have buyer's remorse on this one. So a guy walks into a bar, orders 10 shots of single malt scotch. They're all lined up there on the counter. He takes the first one, picks it up, throws it on the floor. Looks at the remaining 9, looks at the last one, picks it up, throws it on the floor. Bartender says to him, "Why in the world did you do that?" He says, "Well, that first scotch, it always tastes like garbage. And the last one always makes me kind of sick, so I just wanted to get those out of the road."
Oh dear.
Yeah. Better luck
Thank you,
next time with that one.
I'm so sorry. I didn't vote for it. Okay.
All right, so as you can see on the screen, Sam and David's information is there, as well as a few other folks here at Ribbon who can certainly help you out with this topic. So if you have any questions that you didn't get answered here on the webinar, please reach out to these folks. Obviously, you can go to ribboncommunications.com, and there's plenty of places to get a hold of us there as well. Later today, you will be getting an email from us with a link to this replay and a link to the slides as well, so be on the lookout for that. And again, thank you so much for joining today. David, Sam, any last parting words before I close us out?
No, thank you for joining today. Look forward to doing a POC for you, or look forward to talking with you in more detail.
Yeah, I would second that. The proof of the pudding's in the eating. I really look forward to any of you that are interested in seeing a proof of concept where you can see the thing come into reality. It's eye-opening when you see the thing happening in reality.
Yeah, good, no doubt. Well, thanks again, everyone. I appreciate your time today. And again, be on the lookout for those emails coming soon. Take care and have a great rest of your day.